Hello, testing, Java 2250. Today I'm just covering a little additional information in Chapter 7. And this is Chapter 7, page 272. And we're looking at multi-dimensional arrays. Now, multi-dimensional arrays can have many dimensions. Let's look at 2 dimensions with rows and columns, oftentimes used to represent tables of values. A reminder that arrays have a single name that addresses multiple elements of the same data type. So an array has a single array name as a reference that can point to many references, many objects of the same type. The array elements must be integer, must be double, must be character, must be all of the same type. So now we're looking at a multi-dimensional array. The example there, we remember that your rows start with 0, 1, 2, and our columns start with 0, column 1, column 2, column 3. So we are, in effect, looking at a table of homogeneous data accessed through a single variable name, which is the array reference. So if the name of this array is A, it is a pointer to the first element in the array. Wherever that first element is residing in memory, it's a pointer to that reference location, and it knows how many bytes are required for each element, because each element is of the same data type. So the first cell in this table appearing array of multiple rows and multiple columns would be the array name, the row subscript, followed by the column subscript. The subscripts are in angle brackets. Continuing in row 0, the first row of this array by the name of array, row 0, column 1. And the value in array subscript 0, subscript 2, and array subscript 0, subscript 3. So we can retrieve each value saved in each row column intersection by the array name, its row reference, and its column reference, where element indexes are placed within angle brackets. So row 1, column 1 would be referenced by the array name, row element, row index, and column index. And we'd be retrieving the integer, the double stored at that particular element. And the array row 2, column 3's value would be identified as the array name, row index, column index, where the index is placed within angle brackets. To create an array, we're looking at a double two-dimensional subscripted array of type integer with an array name of B. And since I know at the time of execution the elements, I can place the elements in row, the first row, and the second row. So I'm assigning, I happen to know the element values for this array at runtime, so my code includes, for this array, I have row 1, row 2. Now that would look like, remember, your first row is 0, second row has an index value of 1, column 0, column 1. So at 0, 0, for this array B, pointing, a reference pointing to this array model, for array 0, 0, we have a value of 1. For B subscript 0, subscript 1, we have a value of 2. For the next row, which is index 1, 0 is a value of 3, and array B at index 1, 1 has a value of 4. So that's kind of your picture value as you might sketch it in a two-dimensional table value. The important thing to remember is that we start always with row 0 and column 0. Multi-dimensional arrays are maintained as arrays of one-dimensional arrays. Well, that data type is a one-dimensional array. Therefore, array B in the preceding declaration is actually composed of two separate one-dimensional arrays, one containing the values for the first initialer, 1 and 2, that's a single subscripted array, and a one containing the values of the second nested initializer for a single subscripted array. Thus, array B itself is an array of two elements, each a one-dimensional array. So with that thought in mind, the manner in which multi-dimensional arrays are represented makes them quite flexible. In fact, the lengths of the rows in array B are not required to be the same length. For example, in a multi-dimensional integer array named B, at runtime we know the values to be stored in each row. So for this multi-dimensional array named B, integer array B with two elements that represent the rows of a two-dimensional array. Each element of B is a reference to a one-dimensional array. So row 0, column 0, row 1. The int array reference for row 0 is a one-dimensional array with two elements. So we have a one-dimensional array. This is our row, our first row, and it has elements of 1 and 2. That B reference is pointing to this single array. And the int array for row 1 is a one-dimensional array with 3 values. Column 2. and here again 3, 4, 5. This is a B reference to the second row, which has 3 elements as a single dimensioned array. With multiple arrays for creating arrays, this is an integer multi-dimensioned array B. We're creating it now. We don't know the values at runtime, so we can't place the constants in a list to assign the array. So we're going to create a new int array of 3 rows and 4 columns. Here I'm using literals or constants for my row value and my index column value, but programs can also use variables to specify these positions. So this could be a variable value for the row index and a variable value for the column index. And that's because new creates arrays at execution time. Not at compilation time. So our program will compile successfully with constant values for your row index and your column index, or we could have variable values represented for a row position and a column index position, and that would compile correctly. And then at execution, at runtime, the array is actually created in primary memory and arranged to be housed in a contiguous location within current memory. In figure 7.17, which is our init array.java program, and that's a shared student data file. In this program found on page 273 through 274, we look at creating 2 arrays. The first array has the same length to initialize the first row and the second row to the same number of elements. The declaration of a second array uses nested initializers of different lengths to allow for a first, second, and third row array with a different number of elements in each row. So let's look at that program. This is figure 7.17. Again, it's a shared student data file, so you can run your tests on this program as well. It initializes 2-dimensional arrays. So we're going to inspect 2 arrays and print out their values. Public class int array, here's the end to match. Public static void main, we are declaring an multi-dimensioned array with the array name reference of array1. and we're assigning its row element, the first row elements 1, 2, 3, and the second row elements 4, 5, 6. So array 1 is a reference to an array with two rows. Sorry, that's 1 and 3 columns. And in array 0, 0, we have the value 1. In array 0, 1, we have the value 2. And in array row 0, column 2, we have the value 3. In the next row, we are declaring, we know these values at runtime, so we can enter them in as code constants. In the next row, which is row 1, column 0, we have 4. In 1, 1, we have 5. And in row 1, column 2, we have 6. So that's kind of a visual of what's happening in that first declaration. This is row 1, I'm sorry. Rows and columns. All right, then our next statement. We are declaring a new array. It's a multi-dimensioned array by the name of array 2. It is a reference to the location in primary memory where we are declaring the elements of this array as integers. And in the first row of this array, we're declaring elements 1, 2 for row 0, column 0, and row 0, column 1. In the second row, we're declaring 3 as the integer value stored in row 1, column 0. And in the third row, which is row 2, column 0, we're storing the integer value 4, row 2, column 1, the value 5, and in row 2, column 2, the integer value 6. So our visual begins to look like this for array 2. Array 2 has 3 rows, with each row having a different number of elements stored in it. So array 2 points to an array of single subscripted arrays. That house integer values. So that's our visual. Now system.out println print is going to print values in array 1 are row by row are. So we're going to traverse the array by row and print out the values. So it displays the array values by row. We're calling the output array method, and we're sending array 1. So we'll find the output array method. Its argument is a multi-dimensional array by the name of array. This is a copy of the reference that's being sent to this local variable. It's copy the reference now, so it's a pointer to the array 1 reference being sent. Loop through arrays rows. For int row 0, while row value is less than the array length, and we know that arrays know their own length, we're going to increment row by 1, so row is equal to 0. On the inner loop, for int column is equal to 0, so column equals 0. While column is less than a row, array row dot length, and we know that array is, this is a row now, and its own row is a single subscripted integer array, so it knows its own length. We're going to let column increment by 1. We're going to output system.out.print formatted. Our string is to print an integer value with some spacing. And we're looking for the integer value in array reference row 0, column 0. So right now, we're dealing with array, and we're looking for array sub 0, but array is a pointer it received a reference as a pointer to array 1, so it's pointing to the memory reference where array 1 is located. So in row 0, column 0 of array 1's reference is the value 1. So we're going to output 1. Now we're working on the inner loop, so we're going to go through the inner for loop, and column now increments by 1, so column is equal to 1. Row does not change. So we're under this row's control of 0, but we're traversing the columns of row 0. So column is now equal to 1. We're going to output in a formatted way the integer value found at array reference 0, 1. Well, we're looking at array, but array has received a reference to a memory location where array 1 is stored. And now row is 0, column 1, so we're looking at row 0, column 1, where the value 2 is saved. We're still working on our innermost 4. Column is now equal to 3. Column is equal to 2. We're going to print array row 0 sub 2. And array is a local reference to array sub 1. And array sub 1, row 0, column 2. Row 0, column 2 has a value of 3. So we'll output 3. Column increments to 4, or column increments to 3, and 3 is greater than the array row length. We only had 3 elements stored in the first row. So we exit the inner for loop. We print a new line, so the pointer is now at the next line of output as we iterate the for row. And row now increments by 1, and row is equal to 1. We move into the inner for loop, and a column is equal to 0. and we're going to print the reference that array received, which was a reference to array 1, row length, well, it's less than the length of the array, and 0 is less than the row length. We're going to output the integer saved at array referenced, which is array 1, row 1, column 0. So right now row is 1 and column is 0. We have a reference to array 1, row 1, column 0, so we're going to output 4 on the new line where my print head was reserved. For column increments to 1, we're still in the inner loop, and 1 is less than this array row length, so we'll continue system.out print the integer found at array reference, which is a reference to array 1. My row is 1, my column is 1, so array 1, row 1, column 1 is saving the integer value 5, so I'll output 5. Column increments to 2. Column length is less than a array row length. So we'll print out the integer value at array reference. Well, array is a reference to array sub 1, and we want the current row and column value. And my current row is 1, my current value is 2, so row 1, column 2 is 6, so we'll output 6. Column increments to 3. And 3 is not less than a array row length, so we exit the inner 4, we print a new line. So my print head is on the next line of output, and I go back to the for loop. For row is now equal to 2, and 2 is not less than array length. So I exit my output array method, return to the calling of the array output array method, and move to the next line of code, which is system.out print formatted. A value in array 2 are going to be printed out row by row. So we're sending array 2 reference to output array, and we're going to call once again the public static void output array method, which is a multi-dimensional integer array, and we're going to assign array the reference passed by array 2. And we'll iterate again by row, and so under the control of row we iterate through the columns 0, 1, 2, and then next row would be row 1, column 1, 2, until that inner column length exceeds array row.length. And then we iterate row to row 2. While row 2 is in effect, we let column iterate from 0 through its array length. This is a very common way to manipulate traversing an array. So a double subscripted array, we want to visit each array's indexed element. So for row, we're going to maintain row control, but traverse through each column in element. When we're done with the length of the column, we'll exit the inner loop and go back and allow the next row to be incremented. So under row control, we'll iterate through the columns. I think that is discussed. Using nested for loops to traverse the arrays, that is, manipulate every element of each array. So this is a classic way. Under row control, visit each column. Under row control, visit each column. So nested for loops are used to traverse the array. That finishes content for Chapter 7. And your next lecture will begin with Chapter 8. And Chapter 8, we're kind of back to exploring classes and class objects again. With object-oriented programming. So thank you very much.